Hello, Mr. Ari, are you alright? Yeah? So remember, what's the Hamming weight? We talked about this a few months ago.
You eat ham and you weigh how much is the ham?
Okay, just joking. What's Hamming weight?
Hamming weight is like...
Remember the number, like 1111. That's binary. What's the decimal? What's this in binary? What's this in decimal? Which number?
15.
15. Yeah, 15 in decimal. Okay. So this Hamming weight is 4. So can you tell me what are those?
What?
Or maybe look. 1010. That's what? That's 2 to the power 3 plus 2 to the. That's 10. Right? So the Hamming weight of 10 is 2. Hamming weight of 15 is 4. Okay, so can you tell me what I'm looking for here? What?
Oh yeah, the number of ones.
Yeah, the number of ones. Yeah, the number of ones is the Hamming weight. Okay. So that's good. So do you still remember how we calculate the Hamming weight? How do we calculate Hamming weight? Remember? Define Hamming weight. Let's do this. Hamming weight. A number. Hamming weight. Okay. Hamming weight. A number. And how do we calculate the Hamming weight? This is the decimal.
I can move the whiteboard by itself.
Yeah. Okay. What's this? How can we do this in Hamming weight?
We shall...
There are two ways, at least two ways of doing this. Two ways of doing this. Can you give me an example? Like we can convert.
you need to convert it to
string. To string, yeah.
Is it already decimal already?
Decimal, but we need to convert it not to the string to the binary in string.
Is it like 1 1?
No. It's a decimal. It's 15. It's not.
Like a number.
Yeah, it's a number. So we need
to convert it
into this. Yeah. We want it. What function you convert this to this?
A string decimal.
No. If you
binary?
If you do the string str15, that will give you this, right? Yeah. But if you give you the binary 15, you'll give you some variable here. I think it's 0b1111. Okay. And then here, look pin 15, and then you can count how many of 1. So we can do this. Return pin n, pin for binary, yeah. Dot count the what? Count 1, right? So what's the time complexity for this one? We are converting this to this is log n. So it's log n, right? Log n. And we're going through the log n string. So log n times log n. Okay? To count the number of ones. Okay? That's one way of doing it. Okay?
Log n times.
Log n. Log n times log n. Log n squared to the power.
Log n.
Cat, don't bite my cables, cat.
He thinks it's string.
Okay, so the other way, how can we do this?
Huh?
How can we do this? So if this binary is 11000, okay. So
that's a lot.
no, this is binary. How can we do this? How can we do this? How can we can
convert it. Oh no, it's already.
Yeah, we can in binary we can remove the lowermost. Yeah, to 1. Lowermost 1 to 0. Then we add 1. And remove it. Add another 1. And remove this. Add another 1. Yeah? Got it? So how can we remove the rightmost one? What's the rightmost? How can we remove it? Minus 1. And we do what? This is n. And then how can we make it as Eric? How can we make it as 10000? What's n minus 1 here? N minus 1 is 10111, right? Yeah? N minus 1 is this one, right? And n is this one. So what operation I need to do to make it this one? Come on. N, and then there's n minus 1. So what operation I need here?
Is that the n and that's the n minus 1?
Yeah, and then look.
What's that n minus 1?
Look, minus 1 that would be 10111, right? Right? This is binary, yeah? 10110, and minus 1 that would be 10111. So what operation I need to get it 10000?
Oh, I think it's ever excuse it, wait.
How many of binary operation?
Or?
No, if it's all, that's 1, right? 0 or 1 is 1, right? What's the other one?
Wait. What was it?
Or, and, yeah?
And.
Exclusive or, there are 3 kinds, yeah?
And.
Or is one of them is 1.
Exclusive or.
Come on, I just told you. And. 1 is, or is 1. See, one of them is 1, right? And is both one needs to be 1, right? Both needs to be 1, right? Got it? Exclusive or is they are different, right? Got it? 1 or exclusive 0 is 1. 0 exclusive 1 is 1. 0 exclusive 0 is 0. 1 exclusive 1 is 0. Got it? Right? So in this case, what is it? And. So it's n, yeah? And. Okay? So we can do this. So another operation, another one, yeah? Another one.
No.
Define, let's do it another one. F, n, okay? Now let's say answer equals 0.
Another one.
Yeah, the second implementation, wire n, right? Now
Are those together?
No. I'm just implementing the same idea twice. Answer plus equals 1 and what? We want to remove the rightmost one, yes. And what? Equal what?
N minus 1.
No, and return answer. Yeah, got it? So this one complexity is O log n, right? It's better than the previous one. This one is O
Why is
log
it
n.
O log n?
Because first of all, you want to convert this to binary. Yeah, we are looking for the binary. So how many digits? We're going to, if it's 1, then you need to. That's log n, right? In binary. Yeah, got it? That makes sense.
Okay.
So this is one way. This is another way. Actually, if we can also do this, we can also go into each digit. So instead of look, we can do this. Answer plus equals n and 1, right? The rightmost bit, and then we can shift it 1 position to the right. So that will be n shifter, right? N shifter equals what? Got it?
1.
Yeah, 1. Because look, we're looking at the rightmost digit, and n, if it's 0, it's 0. If it's 1, 1 and 1 is 1, right? Now we remove it, we shift it 1. That's another way. But this one is not as efficient as the previous one, because the previous one we are removing the 1 only. We are especially looking at 1s, right? If there are lots of zeros, this one will go through each bit by bit. But the previous one is will just remove 1, yeah? So it's a little bit faster. Alright, got it? Okay, if n is a 32-bit digit, integer, then this takes at most 32 times to finish. Then in this case, we are not talking about O log n, we are talking about O1, right? Because it takes at most 32 iterations if the n is, we know is, at.
Is it that program?
Yeah. Okay. So now, given a number, a list of numbers like 1, 15, 2, 3, we want to sort the numbers by Hamming weight. Okay. So the more Hamming weight, it will be, right. So the more Hamming weight, it will be in the ascending order, right? And if there's a tie. Let's say if binary is 1, 1, 1, 0, 0 or what? 1, 0, right? If you look, the coming weight of both numbers is 1, and we need to put these numbers first because this one is bigger. So we already know that the function, the sort, yeah. So we just have to put a key, right? Define, let's say f lumps, yeah. We just need to do this. Return sorted, okay, sorted. Then nums, right? Look, usually we do this and we can provide a key. We want to sort it by the key, which is what? We can sort this lambda x, fx or gx. This is the Hamming weight, yeah, Hamming weight.
FX.
But that second parameter will be x, right? That's it. So that will look, we are passing this as a new parameter. Key equals lambda x. Yeah, that's the parameter x. And then you will return a tuple. Look, this will return a tuple. The first one is Hamming weight. So basically, you will sort the numbers by two things. One, the first thing is the Hamming weight. If Hamming weight is the same, then you look at the actual value. Okay, so that's what it means. Yeah, got it? Okay, so actually you can do this as well. You can num dot sort, yeah, sort, and then you can do this key equals, this is the same thing here, right? And then return num. This is the same thing. Okay, return sort. And actually you can do this reverse. If you want to sort it from the largest to the smallest, you can do this reverse. Reverse equals true, right? By default it's false, right? So this is sorting, you can do this, passing the parameter, reverse or key, right? Key equals lambda x. So this take an x and return a tuple, which is, the first of all is the Hamming weight, and the second value is the value itself. So when we pass this lambda key, lambda is a short function, yeah, takes the parameter x. We are based on the Hamming weight first. You sorted the numbers based on the Hamming weight. And if there's a tie, if there are two numbers, the Hamming weight is the same, yeah? Can you give me an example of two Hamming weight is the same? Two numbers which has the same Hamming weight, just any example. Come on, the number ones are the same. So what are those? There are a lot of examples. Come on, should be quick. What? Come on, two what? Any example? Think in binary. Hamming weight. Number of ones is the same. So can you give me a two?
Numbers of ones in what?
In an integer a and b. If I say fa equals fb. So what are a and b? Give me example. There are lots of examples. The Hamming weights. The number of ones in binary is the same. Like 15 is 1111. Okay, so can you think about other number which has four ones but different?
Wait.
It's quite easy, yeah? You put a 0 at the end, what happens? If you put a 0, right? What happens if you put a 0 at a binary? What does it mean? What does it mean? If 1 is 1, 1 0 is what?
It is 2.
2, yeah, so 1 0 0 is what?
4.
Yeah, so you put a 0 at the end, what happens? In binary?
It'll like 2 power of them.
Double it, yeah? You double it. So you give me any number and then you double it. It has the same Hamming weight, yeah? 100 and double it, 200. They have the same Hamming weight, yeah? Got it? 15 and 30, right? 15, 30. Same Hamming weight, right? 4. Do you get it? Right? 2, 4, 8, 16. They are all same Hamming weight, only 1. Got it? Yeah? Does it make sense?
Yeah.
Okay. So if they have some Hamming weight, this is the first parameter is the same. Then we'll look at actual value, right? Look at the actual value. So you sort based on the actual value. What's the time complexity if you have a sort?
O log.
So what?
O and log.
Oh, and log n. Yeah, let's see. Okay, let's see for today.
Yay!
Okay. Can you write a Hamming weight function? Come on.
Oh.
Define fn. Okay, come on. Right? And
I'll do the quickest one.
okay, you do the quick one.
Return.
Go to it. Return one.
Return.
Yeah. Return what? You convert it to binary string. How do you convert it to binary string? The function start with b.
Nums.
Start with b.
Bean.
Yeah. Bin.
Bin.
Yeah. Bin. bin. Start short for binary. And then.
N.
Yeah.
Thumbs.
and
Oh,
and
yeah.
and then bracket. Okay, and then what do we do with that?
Wait,
We want to count, right?
count.
Yeah, dot count. Count what?
F.
Count what? What are we doing here? Binary count what? We turn it into binary string. We want to count how many of what? How many what?
Ones.
Ones, yeah. How many? Count one, yeah.
And
Just count the one.
count one.
Bracket. Come on. I just count one. You want to count a function? Count one. Huh? You need a bracket. Come on. Yeah, yeah. And the one needs to be quoted because it's a string, right?
Oh, okay.
Okay. Yeah, and then bracket. Does it make sense, Eric?
No.
It seems that you're forgetting, yeah? I need to do this more, right? Okay, that's it for today.
No.
Bye.